Hi everyone. In this video, I'm going to show you how we can use Apigee and Vertex AI agents to offer an innovative Gen AI-based solar app and interaction demo to users, leveraging data from a variety of sources. So let's dive right in. So as an introduction, we have an API from Google Maps called the Solar API. And it offers a ton of useful and interesting data, right? It provides solar power estimations for geolocations and addresses around the world. It is documented in the typical Google Discovery document format, which is a technical documentation. So it's not an open API spec, right? And it really is a technical data-driven API that really typically needs to be integrated with code. So a developer has to go through this, the amount of data, the large amount of data that's provided by the API and integrate it directly into different, apps and experiences. So the question is can we do this, easier, or what are some options leveraging Apigee and the Gen AI tools in Vertex AI agents? And the short answer is yes. We can do a lot here without having to code, an integration with the Solar API. We're going to leverage Apigee to provide an open API for the data. We've used Gemini and Gen AI to help us build or to specify that API. So it's easy for both developers, but also Vertex AI agents to understand. And this is a big paradigm shift in the world of integration because now Gen AI agents like Vertex AI can understand APIs just like developers can and can leverage them in conversations. So we're going to show that. Then we're going to use Apigee to navigate and connect to the different backend data sources, right? So we're going to connect to Gemini Pro for some operations, so using a large language model. We're going to use the geolocation API from Google Maps to resolve addresses into latitude and longitude, which is a very typical task that normally we would need to code. Apigee can take care of that. And we're then going to connect to the Solar API to get data and service any request that a user might ask through a Vertex AI agent. And this is all with no coding required. So let's jump into the demo. And this demo is structured as a code lab. So we can go through step by step and see exactly how it is structured and how we can deploy it ourselves. So let's dive right in. So here we are in the repository, Apigee Gen AI Solar demo. And don't be afraid, we're not going to code anything or deploy code here. But this is just where the assets are all available, and we can easily push them or deploy them into a Google Cloud project. So there is a code lab here. If we scroll down, and let's go ahead and open that. And this code lab is just gives us step-by-step instructions for deploying the solution, right? There's a little bit of background information. What we will build is we'll be publishing APIs to ApigeeX. The backend services we're going to use, to integrate to Google Maps Solar API and Google Maps Geocoding API, and then we can test everything in a test client, right? Then we're going to publish a Vertex AI conversation agent and show how it can easily as well leverage the API. And then what we'll learn is that, how Apigee can be used to integrate these disparate services into an LLM ecosystem and a Gen AI ecosystem like Vertex AI agents. Gemini Pro can be leveraged along the way with no code. And this can really, be a great model for publishing Gen AI or any type of AI model at scale, right? So managing the access through APIs through Apigee. So let's go right through the steps. And I'm going to do it in split screen, that I'll have the code lab here open on the left side. And then if we go to the first step in the code lab, it recommends that we open Cloud Shell to do the deployment. This is a really practical way to, just have a cloud-based shell and editor that we can use for deployment. So we're going to use that for this demo. So if I go to the first step, open Cloud Shell, so I've got it opened here. It's authenticated with my user, so I can easily work with with my project or any Google Cloud assets that I'm authorized to access. The first step is that we'll need Apigee CLI to do the deployments. This is a CLI command line tool for deploying Apigee assets. If you need to install it in Cloud Shell or any Linux shell, you can just run this command and set your path. I already have it installed, so if I type Apigee CLI and get the results, so I can just go ahead and use it. The next step is to clone the repository. So let's go ahead and clone that into my projects directory, and then cd into that. So now we have everything here locally. And the first step is to open Google Maps keys and credentials and get a Google Maps key. So we will be accessing the Solar API and the geolocation API. So we will need Google Maps credentials key to do that. And so if we just open that, we can select a project. It will give us a key that we can work with right away. So I'm just going to copy that key and then use it here in the next steps of the lab. So I'm going to keep an editor as well open just to keep track of my different keys and stuff here. So then we have that one. The next step is we're going to deploy the Apigee assets. So first we need to set up the environment. I'm going to open the files here in the editor just so that we have them locally here available. So GenAI Solar demo, we can see everything. And the first step is to set the environment variables. So we're going to need a project and a region and an Apigee environment. So you do need an Apigee X, environment and a GCP project as a prerequisite for this lab. So then you fill in those that data here. First, let's make a copy of that file, so we're not changing files directly from the repository. And then in that file, we can fill in the information. So I'm going to use a GCP project called Apigee Test 76. I think, let me check the region. If I go to the Apigee console and then under instances, I can see exactly where the region is deployed. So I'm in Europe West 4. So let's take that. That's in the Netherlands, in Amsterdam. In my environment, we can also check in Apigee exactly which environments I have. I'm here under environments, and I believe I have dev and prod. So we're just going to take dev as a start to deploy these APIs. And we can easily promote them to prod as well. So let's go ahead and source that file. So get the environment variables loaded. And then also set that as our G-Cloud project, right? So if we're using any automation in Google Cloud, it's always necessary to set the project that we're working with in G-Cloud, in the G-Cloud CLI. Okay, so that's updated. Let's make sure all of the APIs are enabled that we'll need. So AI platform for Vertex, Solar API for Google Maps, as well as the geocoding API from Google Maps. Let's go ahead and enable all of those. And then the next step is to create a service account. And this is going to be a service account called Solar Service. We often need Solar or service accounts in GCP to do service-to-service communication. Let's go ahead and create that account. And we're going to give that account the AI platform user rights so that they can talk to Gemini or call any of the AI services. Okay. Then let's also, the next step, store our Google Maps key. So in Apigee, we create a key value map to store any keys or secrets. This has the advantage that that data is available locally to the API proxies at runtime, so they don't have to fetch it. You could also fetch it, from a external key manager, key service, or secret manager, but we're just going to store it here directly in Apigee. It's also encrypted. So we're going to create a KVM, a key value map in Apigee, with the name Solar Keys. Okay, so that's been created. This is also an environment level. So for our dev environment, if we wanted to deploy to prod, we would need to create this in prod as well. We could also create this as a organization-wide KVM, and then it would be valid for all environments, but this is an environment-specific one. If we open the Apigee KVM page, we can then see our Solar Key KVM. And this is under environments. And so I'll select the dev environment and open key value maps. And then we see, there's our Solar Keys KVM where the key values can be stored. Good, so let's go ahead and set the Google Maps key to the key that we got in the first step. And this is setting an environment variable with that key. Oops, not that one. Okay. And then let's store that into our KVM. So there's also an Apigee CLI command for that. Then that writes it into the variable gmaps key, and that's available to Apigee proxies at runtime. So the next step is to deploy Apigee APIs. So we're going to cd into the API definitions. They are in the repository. So we have a Solar Service version 1. And now we're just going to zip it and deploy it to our Apigee instance. So this will first deploy the bundle, and then we're going to deploy it to our Apigee environment here and just overwrite the last deployment. There is no deployment, so this is just going to really deploy it for the first time into our project and our Apigee environment dev. Okay, so it's been deployed. So now our API is ready to go. We can go verify that it's there in the Apigee proxies page in GCP. So let's go take a look under proxies, and there's the Solar Service API. And it was last modified just now. And we could open monitoring or open the definition. And here in the lab, it also shows us a bit, how we can explore the proxy configuration, right, to see exactly what's going on here in this API proxy definition. And we can see that that's still being deployed to dev. Any instances we have in any region or Apigee, either Apigee X or Apigee hybrid instances around the world, would get this deployment then in real time, not as this is pushed out. If we look into the develop section, we can see that we have one endpoint. Let me this dev endpoint offers a /v1/solar service endpoint, and here's what we're doing. We're verifying keys in the pre-flow. We're getting inputs. We're doing some validation. We're getting that Google Maps key that we set in the KVM, and then we're making a decision, right? If we're going to call the get geolocation API to resolve an address, and then we can either go to route to two different endpoints, either Gemini API for any just normal LLM calls to use Gemini, or the Google Solar API as a target, meaning for any solar related questions, right? So this is just typical part of the routing configuration for a proxy to multiple different backends, depending on parameters and things that we can check in the flows. And then in the post flows for the response, there's no processing here. But we of course could add any policies needed to any of these points within the flows. Good. So let's then go to the next step. And that's going to be to test the API proxy. So we can do this easily here in the browser. We can start a debug session. And this basically means we can see the traffic in real time to this proxy. So I'm going to start it for dev. And now we'll see all the requests to this API in real time. So I'm going to copy the URL and I'm going to put it into a variable in my Cloud Shell. And then we can, do a call to our API and for any address, right, and get the Solar data. So I'm going to do this for the Google office in Berlin and just do that call. And you see here we get an error that failed to resolve API key. So our API key policy, we didn't send an API key, so that's why it failed. If we go back to our debug session, we can see that 401 request here, and we can see exactly the policy that caused the error, which is verify API key because no API key was sent. So to solve that, let's create a product in Apigee and then create an app and get a key. So we can do this via CLI or in a developer portal. Let's just do it in the CLI for now for testing. So I created a product, or we could bundle multiple APIs together. In this case, I'm just offering one API, Solar Service. We could bundle multiple together along with paths and other ways of offering different services to users. I'm going to set a test developer here and create a developer in Apigee. Create a developer account for that developer, and then create a subscription to the API. So this would be done normally in a developer portal or some place where developers go to get access. But we're just doing it with the CLI to show how easy it is through automation as well. So you see here we created our subscription and we get our key. So let's go ahead and set that into an environment variable. And then we can do our call again and see if it goes through. Yes, so you see that for our address, we now got a latitude, longitude was resolved using the geolocation API, and we get the data from the solar API, right? So the max sunshine hours per year, how many meters square are available on that roof, how many kilowatt hours could we potentially produce on solar energy per year, and other data points. So cool. So we have our first API deployed. It's tapping into the Solar API and Google Maps for backend data. And you can see here's our successful request here. So we can see exactly the flow that was executed to retrieve that data. And great. So we've completed step one. So we have a fully functional solar power calculation API that offers an open API, an open RESTful API that's easy for developers as well as Vertex AI agents to consume. So now we're going to configure Vertex Agent Builder to connect and use our API. So the first step is we're going to configure our OpenAPI specification. And we have an OpenAPI specification provided in the repository, so we can open it up here in the editor under API specs, Solar API v1. And an OpenAPI spec basically describes, everything that this API can do from all the inputs. So for example, we can pass in an address to the outputs and what you can get from this API, right? So including the solar estimations and data from the Solar API itself, right? But all documented and understandable for developers in a developer portal, as well as for agents who can understand this based on their LLM models. So the only thing we need to change in this OpenAPI spec that's provided, and this was generated by Gemini, for example, right? So this LLMs can help us generate APIs and API specs as well. Is we need to change the server URL because we deployed a new version of our API to our Apigee instance. So let's go to Apigee and get the URL that we used in the previous step to make our call. And so let's go ahead and open API proxies. And we can find this either in the environment group configuration or under our proxy under debug. So there we always have the URL we can reach our API at. So let's copy that and put it into our OpenAPI spec. And we don't need the path. The path is taken care of under paths. We just need the root URL. So let's go ahead and save that. I'm going to copy it. The next step is to create a Vertex agent app. And we can do this here in the GCP console under Agent Builder. And you can search for it or just open it from the menu. The first time that you open it, you might have to enable the API, the service, but that just takes a few seconds. Then let's create a new app. And here we can have different types of apps, everything from search apps that provide a natural language search experience using Vertex AI search to chat to recommendations. But we're going to create an agent app because this can use APIs as well as tools. So let's select that. And let's just give it the name Solar Agent. And I'm going to create it in the EU. This takes a minute to get created. And then we get a default configuration here for our agent. And you see that the structure is very simple. We have a goal. What does this agent want to achieve? And then we have instructions that it will follow, right? Basically kind of playbooks to when interacting with the user. So here in our instructions, we're going to first create a new tool in the tools menu. And this is how we can connect an API into our agent. Let's create a new tool. Give it the name Solar Service. This is going to be a type of open API, right? We could also play with other types, but this is really powerful to connect our API into this agent. And now we need the open API schema. So I copied it from the editor, and this includes our new server where our API is running. And so that's the API specification. Then for authentication, we're going to use an API key because that's what we tested in the first part of the lab. That's in the header X API key. And let's go ahead and copy it here. So we put that in an environment variable. That was the key that we created to test our API with. Of course, we could have a separate key or separate credentials just for the agent. Then we could track in Apigee, how many calls or what kind of calls are coming from agents. So that would be something to explore. Good, so let's save our tool. And now we can use this within the agent. So let's open up the default agent. Here under instructions, we can copy these sample instructions because they're quite good for getting started. And then under tool, we can put in our Solar service tool, right? And the next command is we're not going to use any sub-agent tasks. So just keep it simple. So this agent's just going to use our Solar service. Under goal, we can put this text, provide a solar estimation or addresses. That's basically what it's doing. And then, now we're ready to go. We have the instructions, we have our tool. Now we can go ahead and save this agent. So now we can test the agent here in the window here on the right-hand side. We can already, send a test message. Hi, can you provide solar estimations? So you can see that it already knows what the Solar API provides, right? That it needs an address in the request. So it's asking me for that, right? So I can enter an address. And then we can see that it's going to use our API autonomously with that request, right? Because it knows that, okay, it has everything it needs. It's going to call our API. And you can see that it returns the information from the API here in natural language, right? So that's the solar estimation for our address. You can also take a look at the request response that was sent to the API. And you can see this is really powerful, right? Because you can really connect APIs here as tools into conversations, and you don't need to program anything, right? The large language model can understand it by itself. So that's going to conclude our demo. The next part of the lab is we could do some testing of using Gemini within our API as well. So kind of the other end, it's asking questions to a large language model at one of our API endpoints. And then there's a last part where we can deploy a test website and show how the dialog flow uh, integration can be easily, you know, added to a website, and users can chat with our agent, within a variety of channels and integrations as well. So that's something you can take a look at in the last steps of the lab. So with that, we've concluded the demo and lab using Vertex AI agents and Apigee, and to show you how we can easily offer different backend APIs like the Solar API to users through API and also to agents in a very easy and managed way using these Google Cloud tools. So here are some links and resources that you can dig into. The repository is linked here. Getting started in Apigee is just a prerequisite, as well as taking a look at the Google Maps Solar API and the Vertex AI agent docs. So thank you very much for watching this video. And if you have any questions or comments, just reach out. Thank you.